Okay, so the third and final rule is the quotient rule. Now, there is a proof of the quotient rule. I don't have time to go through it in this section because we need to look at examples of using it. It's not the proof that's so important to you. But quotients, if you think about polynomial division, when we divided something by a divisor, you got a quotient and a remainder. So the quotient is like a division as such. All right, so it's looking at things of the form f of x divided by g of x. All right, so it's looking at functions like that. Functions you could be looking at here is things like y equals 1 over x plus 2 cubed. But I'll show you in a minute why you probably might not want to use the quotient rule for this one in just a moment, if you wanted to go down that road. Again, you've got y equals, I don't know, things like x over x plus 2. So it's cubed again? Yeah, I'll see, it's cubed again. But for these two, this one could be written as x plus 2 to the minus 3. So you could use the chain rule for that one. And then for this one, you could write that as x lots of x plus 2 to the minus 3. That one I'm going to start because I want to come back to it because I'm going to show you how to differentiate that two ways and you can see which is quicker. It's pretty obvious. And the last one is y equals sine x over cos x, for example, if you differentiate tan using the quotient rule here. Okay? So, what is the formula then? Well, the formula is given to you in the formula booklet. I'm not going to prove it because it's already there, right? It's f prime of x times g of x. Take away. Now this is careful, you've got to be tricky here. You've got to be quite careful with this. It's f of x, g prime of x, all over g of x squared. Now that looks pretty nasty, I'm not going to lie. That's pretty nasty to some people, but it is actually pretty easy when you come to look at it. Now, what I'm going to do is I'm going to differentiate this one I was going to come back to. Now, y equals x over x plus 2 cubed. Seems pretty easy to differentiate, right? That's x lots of x plus 2 to the negative 3. Differentiate using the product rule then. So dy by dx using the product rules per se, which is x times derivative of that, which is minus 3 x plus 2 to the negative 4, plus that, the x plus 2 to the minus 3, times the derivative of that, which is just 1. So it's just that. Tidy that up would be minus 3x lots of x plus 2 to the negative 4, plus that. And then you could actually make that even easier for yourself and factor out a bit of factorization going on here. So it'll be x plus 2, you want to factor out the one that's got the biggest power, the minus 4, lots of minus 3x, and then x plus 2. So you end up with that. So it'll be x plus 2 to the minus 4, and then that will be, what is that? Is it, what was it, be 2 minus 2x? So I think you end up with that, which could be written as 2 minus 2x over x plus 2 to the power of 4. So that's using the product rule, which I've done in a previous video, right? Now, with the quotient rule for this one, the x over x plus 2 cubed, yes, you can go and heartily do it to your heart's content, but see how quick this actually becomes. We've got x plus 2, so the f prime of x, the x plus 2 cubed times the f prime, which is just 1, so it's just that. Take away. Now, you have to be careful here, it's minus 3 lots of x. If my flipping thing wants to work today. It clearly does not, which is kind of annoying at some days anyway. X plus 2 cubes. So you end up with that. And then we square whatever was on the bottom, so it'll be x plus 2 to the 6 Yeah, okay. Now, what can we bring down in terms of powers? That should be a 2, so you know. Okay. So we can cancel 2 from there, 2 from there, and 2 from there. So that'll be a 4, that's gone, that comes down to a 1. So we end up with x plus 2 on the top minus 3x all over x plus 2 to the 4. So we've got, hello, 2 minus 2x all over x plus 2 to the 4. Oh, got that using the product rule. So you can see which method is quite quick. Alright, hopefully you can spot that yourself without me trying to tell you which one's quicker. But there is how we can use the quotient rule in order to differentiate these functions. In another video, I'm going to show you some examples of differentiating using the quotient rule.